The intersection of two sets A and V is the set of all those elements we can write which belongs to A and B both. In intersection, we set of all those elements which belongs to A and B both. But in union, which belongs to A, either A or belongs to B. So it is denoted as A intersection B. It is denoted as A intersection B. Theoretically, or set builder form, we can write as A intersection B is equal to X such that X belongs to A and X belongs to B. A intersection B equal to we write as X such that X belongs to A, which also belongs to in set A and also belongs to in set B. If theoretically we solve the problems by taking this type of notation, that means if X belongs to A intersection B, which implies that X belongs to A and X belongs to B. Sometimes if we written in this form, if A is not belongs to A intersection B, what does it mean? This means that when X is not belongs to A intersection B, that means X not belongs to A, or we cannot write as and not belongs to A, either not belongs to A or not belongs to B. We take common element in A intersection B, but X doesn't belong to intersection B. That means that the X either or not belong to B. Okay. Numerically, we can consider an example. Set A, 5 elements, 1, 2, 3, 4, 5. And set B contain 2 elements. So A intersection B contain 2 and 3. A intersection B contain 2 elements, that means common element of both sets. Noted? Abhishek, others? Okay. 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 Next. Next, we define difference between sets. Next is between two sets. Yeah, difference of two sets. Simply we write as difference of two sets. We can define as let A and B be two sets. A and B be two sets. So the difference of A and B, that means is denoted as A minus B and defined as all those elements all those elements which belongs to A but does not belongs to B. Yeah, do not belongs to B. Do not belongs to B. Taking only those elements which belongs to A but do not belongs to B. We can write as A minus B. A minus B is equal to X be an element which belongs to A and not belongs to B. X not belongs to B. Taking all those elements which belongs to A but not belongs to B. Or if you are finding B minus A, so you can write as X such that X belongs to B and X not belongs to A for B minus A. For example, numerical example, we can consider as if A having 5 elements, suppose 1, 2, 3, 4, 5, and B having 4 elements, suppose 2, 3, 5, 6. So what is A minus B here? Which belongs to A but does not belong to B. That means 1, 1 is not belongs to B, 1 and 4. Yeah, 1 and 4. Muskan, 5 is appear in B also. So we cannot take 5. 1 and 4. And for finding B minus A, what is B minus A for this? 6. Yeah, good. So B minus A is 6 only. So this is the difference of two sets. When we obtain A minus B, taking all those elements which belongs to A but doesn't belongs to B. For B minus A, B belongs to element which belongs to B but does not belongs to A. So this is difference of two sets. Noted? Anshika, Tanveer. Okay. Now symmetric difference of two set. Okay, good. Symmetric difference of two sets. We define as let A and B be two sets. The symmetric difference of two sets is denoted as A symmetric difference B. A symmetric difference B, and defined as A symmetric difference B is equal to A minus B union B minus A. A minus B union B minus A. Difference between two sets, we understand previous topic, and here symmetric difference, we can calculate symmetric difference as A minus B union B minus A. Theoretically, we explain as A symmetric difference B is equal to X, such that X belongs to A and X not belongs to B. Or, in place of union, we write or. X belongs to B and X not belongs to A. So we can write an example. That means if A equal to 1, 3, 5, 7, 9 and B equal to 3, 5, 6, 8, 9. So what is the asymmetric difference B? Tanvi, Shivali, Priyanka, calculate this. What is asymmetric difference B for this? 1786. So first A minus B. What is A minus B here? A minus B is 1 and 7. This is 1 and 7 and union of B minus A. B minus A means 6 and 8. Yeah. So you can write as 1 and 8. So this is the asymmetric difference B. Noted? Okay. So you have remembered some properties. Then we move next topic, that means laws, some laws. So remember some properties because we use frequently. If X belongs to A union B, which implies that X belongs to A, we write again, that means or X belongs to B. Second, X not belongs to A union B, which means that X not belongs to A and X not belongs to B. Third, X belongs to A intersection B, which means that X belongs to A and X belongs to B. 4. X not belongs to A intersection B implies that X not belongs to A or X not belongs to B. Fifth, X belongs to A minus B implies that X belongs to A and X not belongs to B. 6. X not belongs to A minus B. X not belongs to A minus B. What does it mean? X not belongs to A or X belongs to B. 7. If X belongs to A, implies that X not belongs to its complement. 8. If X not belongs to A, implies that X belongs to its complement. So these 8 properties we use in problems related to sets, or we prove that so and so, and we use, or this is helpful to solve the problems. Okay. Complement of a set, we denote it as A dash or A complement, that means AC, A dash or A complement, which equal to universal set minus A. That means all those elements which belongs to Q minus A. If A equal to 1, 2, 3 and universal set having 5 element, 1, 2, 3, 4, 5. So the complement of A having only 2 elements, 4 and 5, which doesn't belongs to A. So you can present by diagram. This is universal set. Universal set, that means 1, 2, 3, 4, 5. So this is A and remaining is A complement. This is a complement. Noted? Others? Okay. Ritika? Ritika? Okay. Now we have some laws, important law we use in set theory as well in Boolean algebra and others. So names are same approximately, but operations are distinct in concerned field. Here we use the operation, that means union and intersection. In group theory, we use the operation addition and multiplication. Sometimes we go for the tautology, so we use the operation and or not, and or. So different field we change the operations accordingly, but name are the same. That means we start with the first law. First law is A union, that means idempotent law. Idempotent law. So idempotent law, the statement of idempotent law we write as for any set. For any set A, we have A union A. That means we take union of same set that gives us A, and intersection, this is the first part, and intersection of same set, that means A intersection A, also the A. So we can prove easily. That means first part, when we are going to prove, so we write a statement, let x be an element of, we prove that LHS is equal to RHS part. So we take the element of LHS, that means we make subset of RHS part, and same as we take the element of RHS part and take, say, the uh, subset of LHS part. So we can say that LHS equal to RHS. That means A is subset of B, B subset of A. So we can say that A equal to B. So X be an element of A union A. That means we take the element of A union A. Our purpose is that to show this element is also belongs to A. That means in RHS part, so we can say that the first LHS part is a subset of RHS part. So then we can write X belongs to A union A. This implies that we write as X belongs to A or X belongs to A. X belongs to A, or by the definition of union, X belongs to A or X belongs to A. So we can write this only once. So this implies that X belongs to A. We can write as X belongs to A or X belongs to A. So just we can write as X belongs to A. So we take the element, when we have taken element X which belongs to A union A, so then that element X also belongs to A. So we can say that this LHS part, that means A union A the subset of A. That means all the element of A union A be the element of A. Similarly, to show take the element of RHS part. So again, you can take element as X or you can take as Y. This is depend upon you. So let again Y be the element. Y be the element of A. That means we take the element of RHS part, this RHS part. So then we write as a Y belongs to A. So we can write as, imply that we write as Y belongs to A or Y belongs to A. We can write this as Y belongs to A. There is no effect. So which implies that Y belongs to A union A. A union A. So we can say that if Y be the element of A and this Y be the element of A union A, so we can write as A is the subset of A union A. A is the subset of A union A. This is the equation number 2. So from 1 and 2, because we know that by definition of subset, if A is subset of B and B is subset of A, so this means that A equal to B. This means that A equal to B. So from 1 and 2, here we write as from 1 and 2. From 1 and 2, A union A equal to A. So we can prove the idempotent law. as this way. That means second part you can prove similarly. In place of union, you write as intersection. We here we use or. For union, you write and as intersection. For proving such type of laws, that means only LHS part is necessary. You have to prove LHS part, then to do the reverse process of LHS part, you can get the RHS part. You can see that means here we consider in LHS part, that means X be the element of A union A here, and we show that A union A is the subset of A. Then in our RHS part, we start from here. That means Y. You can take as X, no effect. So X belongs to A, and next step we write this step here. Y belongs to A or Y belongs to A, and next step we write here. Y belongs to A union A. So we write A is subset of A union A. So that means you do only LHS part, then reverse process used for the RHS part. So putting equation 1 and 2, that means from 1 and 2 you write as A unit equal. Similarly, you can proceed the second part. Okay. So we have some laws you can prove similarly. Noted? Others, Shivali? Okay. So try to solve other laws. Note down a second law. We have associative. Associative law. Let A, B, and C be three sets. Then first we write as A union B union C is equal to A union B union C, and second part for intersection A intersection B intersection C equal to A intersection B intersection C. Similarly, you can do this. That means you can take x be the element of this, and then prove. Just a hint for you. You can take you write as x be the element of A union B union C. So first step you write down as x belongs to A union, in place of union you write as or x belongs to B union C. Next step you write as x belongs to A. MST1 will be online, but final exams will be offline. So then you have to ready as offline. Okay. Yeah. First MST, Sahil. But you have to prepare yourself as you give the final examination as offline. So you have understand and note down each and everything. Okay. So x belongs to A or x belongs to B. You write the bracket as or x belongs to C. X belongs to C. So just you can write as x belongs to A or x belongs to B or x belongs to C. So we can write as x belongs to A or x belongs to B or x belongs to C. X belongs to A union B or x belongs to C. So x belongs to. Similarly, you can proceed for RHS part and second part. Okay. But you have to remember the statement of all the laws because we use in questions. Noted? Okay. The next law is commutative law. Commutative law. We know that associative law and commutative law both are the hereditary property. That means for addition, for multiplication, let A and B be two sets, then A union B first part equal to B union A, and second part A intersection B equal to B intersection A. So you have to remember and try to solve as previous. Next is distributive law. Distributive law, let A, B and C be three sets. Then A intersection B union C equal to A intersection B union A intersection C, and second A union B intersection C is equal to A union B intersection A union C. When we solve the problems by using distributive law, we take intersection as into and union as addition. So multiplication we can